In a previous lecture, we discussed about a lens maker's equation as well as the refraction due to the single curved surface. Now we have to discuss the numericals which are solved in a textbook. Let's start from this numerical. The first numerical is example number 6, page number 169. Open page number 169. On that page number, there is the example number 6 is given. A paperweight of refractive index 1.5. That means refractive index, right? We write first of all the given. The refractive index n is equal to 1.5. Refractive index it will be 1.5 of radius 3 centimeter. Here we say that the radius of this spherical part is 3 centimeter. Now the has a tiny air bubble trapped inside it. For the explanation of this, we draw a diagram for this. Let's consider this one is a paperweight. This paperweight at the center, this having the radius 3 centimeter. This having the radius 3 centimeter of this paperweight. This medium having refractive index 1.5. That means this glass surface, this suppose we say that this will be made up of glass surface and this glass surface having refractive index 1.5. Here closest distance of this air bubble from the surface is 2 centimeter. That means here we say that suppose this one is air bubble. That air bubble will be we consider at position O. Its position will be 2 centimeter from the closest end. This distance will be of 2 centimeter. We represent this by r. This r distance will be equal to 2 centimeter. Now, after that, here we say, we read the example again, where it will be appear seen from the other end. It is the farthest. Here we observe from this end. When we observe from this end, that we say that P. Here we say that this CP distance, from this CP distance, which is equal to 3 centimeter. Here OP is the distance through which we observe. OP is the distance through which we observe that OP distance will be nearly above 4 centimeter. Here we have to determine the image where it will be appear. That means we have to find in this example that image distance V. Now we say that this OR, that is CP is equal to R, which is from the towards the left side. Therefore we take it as minus. And also we say that we observe this towards the left hand side. Therefore this distance OP, that distance is object distance, U is also taken as minus. Now we solve this by using the formula N2 minus N1 upon R, which is equal to N2 upon V minus N1 upon U. Now we use the formula which is the first medium and which is the second medium. Now in this case we say that this object it will be having the first medium N1. This will be first medium and here we take N2 is equal to 1. Now we substitute all these values in this equation. Therefore we got like this N2 minus N1, that means 1 minus 1.5. 1 minus 1.5 upon R. R is the radius which is equal to minus 3, which is equal to N2 is equal to 1 upon V minus 1.5 upon U. U is minus 4. We substitute first of all these values. Now we solve this. Here which is equal to minus 0.5 upon minus 3 will be equal to 1 upon V. This minus becomes plus 1.5 upon 4. Now this minus and minus becomes plus, therefore 0.5 upon 3 minus 1.5 upon 4, which is equal to 1 upon V. Now we solve this. Here 4 into 0.5, that becomes, or simply we say that 1 upon 1.5 which is equal to 0.5 upon 3 means 5 upon 30. 5 upon 30 minus 15 upon 40 which is equal to 1 upon 5. 0.5 is converted as 5 and 1 0 is at the denominator. This decimal point we shifted this 0 at denominator. 5 1s are 5 6s are, that is 1 upon 6 minus 5 3s are 5 8s are minus 3 by 8 which is equal to 1 upon v. Now we solve this. 8 minus 18 upon 48 which is equal to 1 upon v. Therefore, in the next step we write like this: 1 upon v, that means here 10 upon minus 10 upon 48 which is equal to 1 upon v. Therefore, v is equal to 48 upon 10 minus 10. We shuffle this or reciprocal of this. V is moving in the, at the numerator, and the next step we write here v is equal to minus 4.8 centimeter. From this we say that image of this air bubble from the other end will appear at minus 4.8 centimeter from the object. Therefore, in the answer we write v is equal to that the final image, the bubble will appear at a distance. The bubble will appear at a distance. Answer we write the bubble will appear at a distance 4.8 centimeter from the other end. In this way, we discuss from the farthest end. We will discuss about the one of the example based on this topic. Now we will discuss another example. From this topic will be, the second example will be example number 7. Example number 7 on page number 170. On page number 170.